bandwidth equal to F naught by Q. See how the formula is getting logically correct here. Bandwidth equal to, instead of F, if you write in terms of bandwidth in terms of omega, it is omega naught by Q. If you write in terms of F, it is going to be F naught by Q. And instead of having just F naught by Q, we are having an additional multiplicative factor root of B square minus 1 plus or minus 2B because of the double tuned amplifier characteristics. So see here, nowhere the amplifier parameters are coming, only the transformer parameters are coming. B is going to be the coefficient which is going to relate to your coefficient of coupling and coefficient of coupling. So the bandwidth is dictated by this term B. The bandwidth is dictated by this term B, and you can see the bandwidth is proportional to omega naught by Q if B is a constant. If you take a finite value of B, this square root will become a constant number. The bandwidth depends only on omega naught by Q. So I can say, see here, the bandwidth is proportional to omega naught by Q. So in single tune amplifier, the bandwidth was exactly equal to omega naught by Q. We have derived that for single tune amplifier, there was no multiplicative factor at all. Correct. So the bandwidth was exactly equal to omega naught by Q. But in double tune, it is multiplied by a factor root of B square minus 1 plus or minus 2B. Okay, so compared to single tune amplifier, the double tune amplifier is going to have a better bandwidth when compared to your single tune amplifier. So B is going to be always positive for any given circuit, and when B is less than this value, the no bandwidth is possible. So B value has to be as large as possible for you to have bandwidth and other maximum power transfer characteristics, correct? So that is why when B value is less than 0.414, there are no real values of bandwidth are possible, because the square root becomes an imaginary term. And bandwidth is a pure integer, right? So it cannot have imaginary values. So when you should ensure, when you design double tune amplifiers, B value should not be less than 0.414. It should be always more than 0.414. So when you increase the value of B from 0.414, the bandwidth of double tune amplifier also increases, because it is multiplied by this term, right? So naturally, when B value is going to increase, the square root term will also multiply with your answer. But at the same time, the overshoot also increases. So you can see in the current characteristic itself, the current actually it should have a single peak and then reduce, but it is peaking 2 times. So this is called as overshoot. Sometimes overshoot can be like this also. It will increase and then it will oscillate like this. So these types of problems will occur if you take B value to be very, very large. See, if the B value is very less, means no bandwidth is possible. If the B value is very large, means overshoot is going to occur. So I need to find a boundary case where my B value is going to be optimal. So the optimum range for B value is between 1 and 1.7. So ensure that 1 is going to be the boundary which will fix the value of B more than the critical value of coupling, right? So if B is equal to 1, that is going to be the critical coefficient of coupling. So definitely B cannot be 1. B will be always slightly more than 1. The maximum value of B which can be possible in practical circuit is 1.7. So you should ensure that the optimum value for B is between 1 and 1.